Okay, good morning friends. So today we are discussing about electric current. Electric current. Okay, nice. So this is the basic topic today. So basically the electric current is to be defined as the flow of free electrons is called electric current. It is measured in terms of amperes. So the units is I. For example, if I consider a value, then we can say it as 10 amps, 20 amps, 30 amps, and etc. So if simple clarification, I can draw some image, then you can able to understand simply. So let us consider a conductor. So let us take this was the conductor, and here it is having, and here is the conductor. Okay, nice. Then for example, the type of the conductor will be copper, and here you have the cross sectional area. So if you pass electric current by using external battery or any kind of a source, let us say we are using a external battery source, and here you have a plus and here it is minus, and then let us assume here we have a free electrons because it is a conductor, we have free electrons, and this is the cross sectional area. Okay, and then let's the movement of the current will be in this direction, and this current will be flows in this conductor from this way to this way. So let us assume, for example, current I should be defined as, we have a formula that is known as I is equals to NE by T, where in other words this is also known as Q by T coulombs by second. It means how much time, here T means time, how much time is taken, that's the charge will be passed from one point to another point, it is known as a current. Okay, and here we can N is the number of electrons, and E is equals to charge of the electron. Okay, as we are also know that let us assume a 1 ampere of a current should be flowing in the circuit. Basically current is known as number of coulombs per second is known as a current. We are simply called as a current. That's it. And just wait. So this is the basic about electric current. Okay, while move on to the electromotive force, let us consider as EMF, electromotive force. Electromotive force. What is electromotive force? So what is electromotive force? The energy that is required to drive an electric current in a circuit is known as electromotive force. Okay, once again I'll tell you that the energy is required to drive an electric current in a circuit is known as electromotive force, and it is also known as EMF. The potential difference between 2 points. Let us consider this is the 1 point and this is 2 points. The potential difference between these 2 points will be known as the electromotive force, and in other words it can be called as voltage. And the units for EMF will be volts. It is denoted by the letter V. Okay, simply an electron in an atom, we are having electrons. If an electron will be moved from one point to another point, it is known as a current. The force which is used to move the electron from one point to another point is known as voltage. Clear? And the units for the current will be amperes, and the units for the EMF will be volts. And here we have the symbol called as I, this is the symbol, and we have symbol V for voltage. That's it. This is the basic about electric current and electromotive force. In other words, it can be known as voltage. Okay, right? And while move to the another topic, we are having as a resistance. In our childhood, we are all learning about resistance. Resistance is to be defined. Just a minute, guys. Yeah. Okay. Resistance is to be defined as the property of a substance due to which it opposes the flow of electrons is known as resistance. In simply, the property of a material which opposes the flow of electrons passing through it. For example, if we have a material, let us consider this is a material. Every material having some resistance. If the value of the resistance is more, it doesn't allow the, let us simply understand with this circuit. For example, here we have a circuit. Let us consider here it is, okay, this is the symbol of a resistor. Firstly, this is the symbol of a resistor. It is having a R. It is written with letter R, and the units will be ohms. If it is, it should be written as 10 ohms, 20 ohms, 30 ohms, and etc. And here it is known as a resistance. Okay, nice. And we have a formula that triangle. We are designing as a triangle. R is equals to voltage by current. Here R is the resistance and V is the voltage and I is the current. Okay, understand? Okay, let us consider. Let us draw a picture. You can able to understand. Here we have a resistor, and here we having a cross sectional area. Let us, this should be known as AM square. It is a cross section. If the cross section of a material will be increases, the resistance will also be increases, because resistance is directly proportional to the cross sectional area. If the resistance value will be increases, the cross sectional area also, or differently, if the cross section is increases, the resistance also increases. That's it. Have you understand? Okay, right. This should be the basic about electric current and motive force and resistance. These are the three, and these three are denoted by a triangle. It should be a triangle, and this is the triangle. Here we have the equal to IR and I is equal to V by R. So simply we can able to find out any kind of a value by using this triangle method. I think you should all understand about this method. And let's see. Okay. Shall we move on to another topic? Okay, nice. I think you should all understand clearly. Okay, nice. Okay, let's see. Okay, move on to next topic. It is known as, just a minute. And this is conductance. Okay, conductance and conductivity. Okay, basically we are all know that we have a resistor. Okay, we resistor having some resistance. Okay, conductance, it should be defined as the reciprocal, means the opposite of a resistance is known as conductance. The conductance will be denoted by the letter G. It is denoted by the letter G, and it is measured in terms of mho, and the symbol will be quite opposite to the resistor symbol. It should be like this. We are all know that resistor will be like this, so this should be opposite. So this is the symbol for conductance, and the reciprocal of resistance quite opposite to the resistor is known as conductance. Okay, we have formula that G is equals to 1 by R, and G is conductance and R is resistance. 1 by resistance is simply known as conductance. And this conductance is also known as specific conductance. In strictly you can call it as specific conductance. Okay, nice. While moving to the effect of temperature. Okay, can we write here itself only? Doesn't take. Effect of temperature. Okay, in general, okay. And in general, resistance value will be changes from change in temperature. Means if the value of the temperature is changes, then the value of the resistance will also be changes. So in this kind, if the temperature, let's forget about all those things. If we have a pure conductor, means a pure metals, pure conductors, if the temperature increases, the resistance of those pure conductors will also be increases. If T increases, resistance is also increases. This should be for pure materials, and the increase is large and regular for normal range of temperatures. Okay, the temperature graph will be straight line, hence the metals having a positive temperature coefficients. So the metals have positive temperature coefficients, means if the temperature value is increases, then the resistance value also increases. For electrolytes like insulators like paper, mica, glass, plastic, and these are known as resistors. And also for semiconductors like germanium and silicon, it should be decreases with the increase of temperature. If the temperature value is increases, the resistance value will be decreases for insulators and semiconductors. That's it. Okay. For alloys also the resistance value will increase, the temperature also increases. Okay, for simply you can able to draw a picture, then you can able to understand simply. Okay, right. And in this fashion we have this, here is a point we can able to use known as R0, and here is the point, you can say it as RT, temperature degrees, and here is the actual temperature. This should be in terms of minus temperatures, anywhere you have a 0, that's it. So this is the fashion, means the effect of temperatures on a alloys, on a conductors, insulators and semiconductors. So for pure for pure conductors, the temperature value increases, the resistance value also increases. For insulators and semiconductors, if the temperature increases, the resistance will be decreases. This should be the main phenomena. I think you should all understand about all those things. I think this is the main also. Just a minute. Okay, let us define a law that is known as Ohm's law. In electrical terminology, Ohm's law will be the main law. This law will be applicable strictly only in temperature will be constant. If the value of the temperature will be constant, the current flowing through the conductor is directly proportional to the potential difference applied on it. Means, for temperature constant, the ratio of the potential difference between 2 points of a conductor to the current flowing through a conductor is constant, provided temperature of the conductor is unchanged. Simply, V by I is equals to R. Then, when the temperature will be constant, when this condition is only satisfies, this condition will be applied. V by I is equals to R. That's it. And simply, as we already discussed about, R is equals to V by I, and I is equals to V by R, something like this. Let us simply draw a graph, then you can able to understand easily. Here is a current, here is a voltage, and we have the line. So if current increases, the voltage increases. If the current increases, the voltage increases. So directly proportional, these are. That's it. Okay. And this Ohm's law is not applicable in temperature changing materials and also non-linear materials like carbon, tyrite and electric arc, etc. And also for semiconductor devices, this law is not applicable. In the same way, in vacuum tubes and gas filled tubes, it is also not applied. And electrolytics and aeronaut gases are provided the electrodes, and this is also it cannot be applied. And in arc lamps also it is not applicable. So that's it. This is the basic about a quick Ohm's law. So let's move on to the next law, and it is known as a Kirchhoff laws. Kirchhoff law. Okay, nice. So basically the Kirchhoff laws may be mainly divided into two types. This is one is KCL and second one is the KVL. Here KCL means Kirchhoff current law and KVL means Kirchhoff voltage law. This law represents the characters of the currents in a circuit, and in the same way this law provides the characteristics of a voltage in a circuit. Okay, basically in a Kirchhoff current law, okay, let us Kirchhoff current law. This is KCL. In this KCL, when algebraic sum of all the currents means and all the currents like I1, I2, I3 and all the currents in a meeting in a single point is to be same as the algebraic sum of all the currents leaving from the same point, means the entering currents in a circuit is equals to the leaving currents in a circuit. Simply you can able to understand by a simple diagram. Let us consider this is a point and we are having some currents, incoming currents. Let us consider this should be the three currents. This is I1, I2, I3, I1, I2 and I3. These are the three currents entering in a single point. Okay, and all the entering currents that must be have to leave. So these three currents are entering in a point, only two currents are leaving. These two currents, let us consider this is I4 and this I5. From this KCL statement we can simply denote as I1 plus I2 plus I3 is equals to I4 plus I5. So this statement will be satisfied according to the KCL statement. I think you should all understand about the KCL statement, right? And you can move on to the next statement, and this is KVL. Let me take a paper. Okay, let us take another paper. I can able to understand something. Okay, fine. We'll move to the KVL statement. Kirchhoff voltage law. This law states that algebraic sum of all the applied voltages and voltage drops around the closed path is 0. Means the algebraic sum of all the EMFs and algebraic sum of all the voltage drops. Here voltage drops mean be losses, that is IR losses, means the heat losses. IR losses is equals to 0. This law states this simple point. This law will be rounds around this point only. Okay, let us draw an image. You can able to understand simply clearly. Let us we have a voltage source. This was the point A and this was the point B, and we are having it is a plus and it is a minus, and we have some voltage V. Understand? If this is the direction, so the number of currents, let us close the circuit, and here is some resistors and something etc. The number of voltages around in the path and voltage drops, that should be equals to 0. It's a simple thing that should be understand by the Kirchhoff voltage law. Okay, nice. This should be about Kirchhoff current laws and Kirchhoff voltage law. Let us discuss some interesting topic about resistors series and resistors parallel. Okay, for example, if you all know that, oh my god, we all know that resistors symbol, resistors, it is the symbol of resistor. Here it is. For example, this is the first node and the second node. Let us consider this one is the R1 and take another resistor. This one also node 1, node 2. It is R1. For example, if you want to connect these two resistors in a series, simply we can join like this, two resistors. Here it is R1 and here is R2. So these two are in series. The formula will be R0 is equals to R1 plus R2. We can able to find out the value. R naught value. This was the resultant value for two resistors are in series. Okay, let us move on to the next topic. For example, if the resistors we have to connect in a parallel, let us consider the two resistors and we have connected these two resistors in a parallel, and here is the one resistor and here is the second resistors. So in this fashion we have to connect these two resistors and we have the nodes at here, and this was the first node and the second node. Here it is called as R1 and it is to be R2. The resultant R naught will be defined as R naught is equals to R1 R2 by R1 plus R2. This was the resultant. From this formula we can able to find out the resultant when the two resistors are connected in parallel, like this. In this fashion we have to find out the resistors that should be connected in series and this unconnected in parallel. So this was the parallel connection. So I forgot it. So like this you can able to define. Let us simply find out this series and parallel with a simple example. Let us consider some value we have cabled as how it is works. Okay, here R1 is equals to 10 ohms and R2 is equals to 10 ohms. Okay, find out when two resistors are connected in series and parallel. For example, in series we have the formula like as R1 plus R2. So simply it should be 10 plus 10 becomes 20 ohms. That's it. And in parallel, 10 into 10 by 10 plus 10. 10 tens are 100, 100 by 20. And the simple answer will be how much? This 0, this will cancel, and 2 10 by 5, 5 ohms. That's it. In this fashion we can able to find out the resistors connected in series and parallel. That's it. This is a simple example. Okay. Okay, let's discuss about machines. Machines. So basically machines are of two types. The first one will be generator. The second one will be motor. So we have to discuss about first thing will be generator. Okay, what is a generator? Generator is a device which converts the mechanical power into the electrical energy or mechanical energy into the electrical energy. This is a generator and we are giving a mechanical input and it should give the electrical output. That's it. This is known as a generator and this is a generator. Okay, and while moving to the motor, the motor is a device. For example, this is the motor. And it is a motor. So motor is a device, it is a motor, and we are giving a electrical input and we are getting the mechanical output. So this is the motor. For example, the generators will be like as a DC generator and dynamo. And this is called as three-phase induction motor and DC motor. Let us draw an image, then you can able to find out simply. Classification.